Hello guys, I'm really sorry about disappearing, and now in this long video I will be explain why I was been disappearing, and actually you can see what the project I was been doing for my university, and I really hope you like it. So like, subscribe and enjoy it. My name is Alexander Zaslavskis, and today I'll be showing one of the projects I've done for my third year, which is ESP-based smart home system, and it will be a quick demonstration, and I hope there will be some questions about it. So, yeah. So, the main concept of the project is following. We have two modules which I have right there. So this one is main hub, which basically monitors all other modules. This one is a relay module. Honestly, the relay is just an example. I can switch it to anything like relay. It could be whatever. But the trick here is the system. It's an like mesh network, and it's decentralized, and it doesn't have any servers which it requires for running. So on the slide you can see the overall concept. This module, the main hub, is connecting to the Wi-Fi and basically getting an web page generated from it. However, the second connection it has, it's ESP-NOW protocol, which connects to the all other modules. Wait a second. To the all other modules, and basically just collects all the data. So, and a block diagram of the circuits will be following. So the only difference between these two modules is that the second module has a relay. So inside each module has a same PCB, same connection, same everything, but it's just different module for different purpose. And of course, it has different software, so the firmware is different. However, the hardware they're exactly same except the relay. In terms of hardware implementation, you can see semantics here, and one of the main idea is that we have an modular design. So you have a large amount of pin headers where everything can be connected. It has I2C, it has SPI, it has just general pins, so you can build your own system on top of it. However, here we can see couple of schematic decisions which can have some questions, and one of these is this resistor on top, which is just safety resistor in case I mess up with my level shifter for LEDs and I need to fix my board. The level shifter is required because an ESP32 requires 3.3 volts. However, my RGB LEDs, which I'm using, needs really 5 volts, so I'm using the level shifter for it. Another thing is I'm using DC-DC converter for making voltage more appropriate for ESP. But here I'm using combined approach. So DC-DC does all the job from taking like from 12 or 24 volts to the 5, because it's very efficient and it can like decrease this voltage very nicely. And then a low dropout regulator takes 5 volts and turns it to the 3.3 volts, which is more efficient way of converting and much more easier. The reason why I can't use one DC-DC converter to the 3.3 volts is just because my LEDs require 5 volts, so it will be another DC-DC to get from 3.3 to 5 volts, and it's more complicated to take 5 volts to the 3.3. Hardware implementation. So as we can see in a PCB. The idea behind PCB is to make it like modular, so you can connect the pin headers, connect whatever you have on top, and build your custom design on top of it. However, right now we have some issues about it, and I'll be talk about it later. But here you can see design in a keycard which has been done for this project. case implementation. Um, as you can figure it out, the project has a case which is just somehow protecting my PCB and my components from all the stumbles. Unfortunately, it's not perfect. So my initial idea was being to keeping an elite on a friction. However, you can see an rubber band here, and it's a problem because the tolerances of 3D printer are not so perfect, and I can't only rely on this. In my second version for my relay module, I'm making a latch. However, the problem is I have only two latches instead of four. So this is why it's not really fixating it very well, and it tends to slide off. So there's some work to do, but in any case, I think it could be acceptable level as I'm not mechanical engineer.
And I see you've also been a mechanical engineer.
My main focus is electronics, but I'm still trying to keep my skills better in 3D designing and software implementation. So talking about software implementation is that we have a very simple code which is split in a different tasks and a free task. But in short, we can describe it like that. So the system awakes when it gets the power. It sets a configuration and checks if Wi-Fi configuration is on. Then it basically checks if does it has an IP address from Wi-Fi router. If it gets, it runs Wi-Fi web server and then tries to run LED server and then setups ESP now. And lastly, registers receive callback, which is basically a very simple piece of code which receives the data from ESP now and basically just brings it to the data processing unit which is processing. And then it's basically running all other systems which require for working. In terms of data processing unit, it's like very interesting because what it does is basically just taking the data when it's received, then it checks if it's in a valid format, has checksum, not corrupted, and then basically just processes. If it's okay, it just generates a new JSON and pings to the web server task. However, if it fails, it just logs in a console that something went terribly wrong. Another thing I need to think about is I have multiple tasks, something like 16 tasks in different importance. I didn't have all of them in the slides because it's too many of them. However, the important thing is remember how it works and how FreeRTOS works, because FreeRTOS is actually scheduling tasks in a different time. Here's a trick that I need to remember which task is right now running, and lastly, I need to balance them between cores. As you can see, for core 0, we have FreeRTOS scheduler, it's by default. We have temperature reading API, we have ESP data processing, and we have CLI processing. It's 4 tasks, and for core 1 is just a web server, JSON generation, and data processing. Why? Because these tasks are more intense and it requires more CPU power. So as the cores are exactly the same in terms of performance, I just decided to split like that. So, in terms of software implementation, the software is based on the ESP IDEA framework, which is awesome too, very flexible, very nice. However, it's very complicated and it has very steep learning curve, and it takes me a long time to actually create an app. software prepared for this. Another thing you can figure it out is that all my code is separated to the different components. So my CLI is in one component, my display code is in a different component, my storage is basically in a meta component. So it doesn't have any code. However, it has special configuration for data storage. So it can upload web files, which I'm using for web page, to the basically ESP microcontroller, so it runs on top. For my JavaScript, I'm using framework CodeSvelta and components from Flowbyte, which is very nice in terms of making awesome web interfaces. For actually displaying web pages, I turn my Svelte JavaScript web page to the static HTML, which is 300 kilobytes, but it looks awesome. So, and lastly, it has two endpoints. The first endpoint, which has an all web page, and second endpoint, which has a JSON, which constantly updated by web server in an ESP, which allow to update data from the unit. So, any issues? Of course, there's been a lot of issues. Issue number one was being, you can see a green wire soldered to my PC. It's just because when I've been doing my design, I have human mistake, unfortunately. One of the good decisions what to do in the next to fix that is just to check PCB design after 24 hours or 72 hours after I finished it, because these mistakes are very easy to spottable. You basically head look to the PCB, you're seeing that something is not right, then you say it, and then you sort it. The next thing is this signal from the scope. So the blue channel is in a signal coming on my level shifter, and the yellow channel is my signal from the level shifter. And as you can see, there's nothing on the yellow channel. Why? Because by accident I soldered it. Remember that jumper resistor I have? So by accident I soldered it and shorted my level shifter. So after I desoldered it, it was been working properly. And the last thing is about these two transistors, which we've been using for flashing ESP32. The schematic works perfectly fine. However, one thing I forget about it is reading datasheet. Turns out I don't really need them, because ESP-S3 supports uploading data by, as you can see, just basic USB port. And when you're using USB, you don't need these transistors to reboot microcontroller. It automatically can handle it in a software way. If you're curious how it does, if I correctly remember, it uses JTAG under the protocol. Basically what happens, it just implements stop controller, so it runs 5 cycles and then reset microcontroller and then it's ready for uploading. So another issues there's some issues connected with my initial design and my initial concept, which is basically making this PCB as a module which you can put on top PCB solder. However, during the manufacturing, they just can't make it possible, so we need to let to the usual non-SMD design. And one more thing was about ordering the parts from Chinese stores, LC, ESC. The problem was about the taxes and fees. Unfortunately, I have my budget limitation, £120, and some time limitation. So ordering the parts from overseas was being expensive and very time consuming. So I needed to change my design, and fix for that problem is before you're doing any design, you're checking where you can get parts for how much, and then you're ordering only. So we have a two-gun diagram, the plan and the actual. Due to delays caused with PCB and redoing my concept, the project was being really shifted, and it just led to a lot of stress for me in terms of designing software. But in overall, it ended up very well. It works perfectly, so it's no problem about it. So it's perfect, and I'm happy. So I think time for a little bit demo, and then we can have for the questions. Here's a demonstration right now. So we have first plug in our main module to see it booting. Yep, boots up. So it's 10. Yes. Then we have our API connected, and it just awaits connection from the second module, and as we plug in. So finally, we have a data. So if we start heating it up, we can see it's
On the
very slowly, but it's updating.
which one are we looking at? Temperature or external?
External.
External underscore temperature.
Yeah, so you can see 30
Jump to
degrees.
30.
Bulb is glowing, and yeah, so it's how it works. So yeah. So time for question finally.
All right. So bearing in mind you've got a sensitive analog front end for the Wi-Fi module, had you considered any electromagnetic interference from your DC to DC converter? Because it's a switch mode component, isn't it?
Brilliant question, honestly, because you're absolutely right. Because it will be definitely interference on my Wi-Fi and ESP now. However, in my opinion, I think the switching frequency of my DC-DC is a couple megahertz, and Wi-Fi is working in couple gigahertz. So technically, yes. Like in theory, technically, like some 10 harmonics of this like frequency can affect, but in reality, it will be not such a big difference in terms of signal, I think.
Okay. So bear in mind you're using ESP now for the communication scheme.
Mhm.
Is that duplex, simplex, or half duplex?
Good one. Good one. Honestly, good question. I didn't really know because I didn't check, but I suspect it possibly should be half duplex because it's not really like data intensive protocol. And remember, as far I got it, it based on top of on the top of Wi-Fi first specification. If I'm correct, it uses half duplex. If I'm correct, but I'm not sure.
It does use half duplex, yeah.
It does. It does.
So it could also use full duplex. So what type of scheduling method does your microcontroller use for tasks? Is it
For
round?
task. Okay.
Is it round robin, preemptive, or non-preemptive?
By now, I'm using preemptive as I configure it. As it's preemptive, just because, yeah.
How do you know what's the most important task to run?
Technically, the most important. Well, by now, I'm just deciding myself, like just making in a small analyze, like what happens if this task crashes. For example, if the task for web browser crashes, it's not really nice, but you still can have some data from JSON or something. If, for example, a task which is responsible for I don't know, for temperature crashing, you can get your temperature, which is not really nice. The module can be overheat and burn in flames, and you need to call to the
Not ideal, yeah.
local fire department, ask them to help.
So what unit of measurement is RSSI in?
Honestly, it's very simple. So simple. So technically, it just gets an RSSI. So when the packet it's received by ESP now in a struct which is used, it gives an RSSI of received packet. I'm pretty sure it's not accurate. But for understanding, so basically for this RSSI, it basically shows something. However, there's some things to consider. If it's closer to the 100, probably you should start worrying about your signal and interruptions.
It's closer to 100.
200, 100. So the best signal is 200. The
For RSSI?
yeah,
Are you
for
sure?
some reason it's very strange. Like it's from 200 to 200. Don't ask me why. It's very strange.
Typically, the
So I'm in the process of editing this video, and I figured out I'm completely wrong about units which ESP IDF uses for RSSI. To understand what's going on here, we need to check on the code. So received data.RSSI equals receiving from control RSSI. So it's where we're taking our RSSI. So we're checking documentation and we see it's in a part of large struct called Wi-Fi packet array control. So we go to the source code of this, which is in a file ESP Wi-Fi types native, and we can see signed RSSI is received signal strength indicator of the packet unit dBm. So the correct answer is dBm for this question. Because honestly saying, it should be taken in a voltage for ADC. However, I was being unable to read properly ADC from internal ADC of the chip. For some reason, ESP has very strange configuration of ADC. And in terms to read it, it's very complicated, and I didn't have any time to properly configure it.
It could be, so in the older variants like the ESP32 Vroom 32D, you couldn't use the ADC if you had the Wi-Fi enabled because it shared the same core, some peripheral part of it. That was in the errata, which was annoying. So it might be because of that, but this is an ESP32 S3, right?
Yes.
Yeah, so they may have fixed it by now.
Here's a trick: is they really significantly changed NZDK as well. And in ESP IDF4, you can quite easily get the voltages from ADC. In the last version, which is 5, it's like very cumbersome to do.
Yeah.
Because it's like requires a lot of. So imagine your ADC config in the beginning asks the method of sampling you need to get an voltage.
The method of sampling,
And
like one shot or
so it's,
continuous?
Sorry?
What do you mean by method? Do you mean like single shot or continuous?
Yeah.
Okay.
It's like, but
And like scan mode. And stuff.
scan mode, things like that, yeah.
Okay.
This configuration is sometimes like a little bit tricky.
Recently, I mean, I haven't done ESP development up until recently, and I updated to 5.4.1, and it's broken all of my old projects. So I had to change a lot of things, but that's good to hear.
Like, I didn't hesitate about ASP idea. It's very nice. Very nice, but it has some like some things you're like, come on guys, why, please, why, tell me. Like, remember we've been talking about internal temperature sensor. So for some reason, when it doesn't have any data, it can show plus 53 degrees. Like if it has an error getting of the data, you're like, why 53?
That's very specific.
It's like
that may be it seeing all one represented as a signed 16. No, it wouldn't be signed 16 bit. I'm unsure. That seems unusual.
It's like very unusual. And when I was been reading official documentation, I was being like, guys, why you did it?
So your temperature sensor, is it an analog or a digital one?
Which I'm using for external temperature. Digital, it's DS18B20, which is very nice.
Okay.
It's a digital one from Dallas Technologies.
Is it one of them one-wire communication?
Yes.
Okay.
It's 1 wire.
Fairly slow. Okay.
Very slow, yeah, but you didn't need really quickly updating temperature, so it's fine.
So,
It's awesome.
do you know how much power consumption one of these devices uses?
The best test showed completely working PCB was being like, I think 80 milliamp with everything, with LEDs on, with Wi-Fi, with everything, if I'm correct.
80 milliamps is pretty good.
Yeah.
That's not bad for. Well, is that constant communication? So is it sending data every second or so to the main?
Connected to the Wi-Fi, and it's receiving data from the module.
80 milliamps is not bad. That's pretty good.
And LEDs are on.
Yeah, and they're quite bright as well. That's probably
Yeah.
where most of your are they WS2182B LEDs, the addressable ones.
Yeah.
So I think they can take. I think.
Nope. It was being SK6812.
Oh, the small dot star ones.
Yeah,
Oh, okay.
just because it's only one you can buy the most of for some reason.
I do have 100 of them from Amazon, yeah, for like £4. Okay. So, how many devices can you bring online? I know we've only got 2 here, but if you had another one, could you turn that other one on and then it auto connects?
Technically, the plan is it does unicast and basically the main hub. So the main hub is basically first thing it checks MAC address by device. Technically, unless the memory of the stack is full, because it doesn't use any ESP32 features, ESP-now features for like addressing. It just basically unicasts to the every device, and then just basically by MAC address they understand which one is which.
Okay. So is it the one with the highest MAC address value is then the controller basically?
Yeah, but by now just hard code. You just hard code which one's controller, which one's not.
Okay. If I gave you a time machine and you can go back in time, what would you do differently on this project?
Good question. And I was already thinking. Probably thing number one, what I was been doing different in this project is first about my PCBs. I would firstly check which suppliers I can get, and then I will be starting ordering my components. It's first thing. And second thing, I would change probably my microcontroller for different tasks. By now, I'm using ESP32 S3 and ESP-now. In reality, in modern market, better choice was being ESP32 H2 with Zigbee. Because Zigbee is more popular and you can like buy the Zigbee devices. So
Had you thought about the ESP32C6, which supports Fred and Matter natively?
sorry?
So had you thought about the ESP32C6 variant,
Yes.
which supports Fred and Zigbee and Matter?
Yes, or that particularly, yes. Another option, yeah. Technically, I could also go with 61, which supports 5 gigahertz Wi-Fi as well.
I believe so. I think the C6 supports Wi-Fi 6, but I may be wrong on that. I've only glanced at that data sheet.
But here's a tweak. By the time I started this project, C61 was being on the new project.
You say C61?
Yeah, I think the last one was 5 gigahertz. I think it would be just like sending samples or something. It's not all chip.
I haven't even heard of this. This is new to me.
I think, yeah, it's very fresh something.
That's actually quite nice. This Wi-Fi 6.
Yes,
Single
it's
core.
Wi-Fi 6, not Wi-Fi 5. Sorry.
Right.
It's like very fresh. So,
Do you like the AI image they've used?
yeah.
If you look closely at those pins, they don't look quite right.
But it's like very fresh. And it's basically very nice because I have Wi-Fi 6, which is widely using now. Everything. I have Bluetooth, I have everything. But by the time I done this project,
It's a very good platform to build off of, basically.
yeah.
And it's a nice module. So it's not your fault that they weren't fabricated the first time around. It's because there was ambiguity in the supplier not understanding that you wanted sliced castellated holes, which is normally absolutely fine. It would be, mitre sawed down and it would be okay. There was just confusion about what was required and there wasn't enough time to get it done quickly as all. But we got there in the end anyway. You made the device and it works.
Yes.
It works well. In terms of your sensors, what sample rate did you use? How fast do they collect the data?
For temperature every second.
Every second, eh?
Every second, yeah, every second. And it's even more interesting because, for example, here I have my 2 DH sensors. So what happens? It goes through all the waits for a second and starts again. So checking all sensors in a bus. Usually it has one sensor, however, it can be much more, like 2, 3, 4, 5.
Does that happen in one single thread?
Sorry?
Does that happen in one thread?
Yes.
Okay.
It's like, honestly, yeah, it's in a thread, but honestly, I here should use the word task because it's a separate task. So in my software, what I'm doing, so how it works, it has a separate task and separate like static memory and some memory that is accessible for my different pieces of code. So what it does, it has an array of amount sensors it has. So it puts an values in it, and every time in the code I need my temperature sensor. I didn't ask for new. I just take the collected
Yeah.
that was being done before, and it updates every second, so it's not very old data.
Do you experience any packet loss or anything like that?
Yes, unfortunately.
You do.
Yes, so it's very not nice. Very annoying.
If so, how much packet loss?
I can't tell you real figures, but I was being figured out that it tries to get my web page uploaded to the web browser, and then in the middle it just stops because it just and it drops like completely almost all the packets, and then it stops by timeout. So it's starting dropping packets, trying to re-get it. Unfortunately, timeout cap and just my web page.
So does this utilize TCP or UDP?
TCP or UDP. Technically, in a stack for web page is TCP/IP. It's TCP/IP. For ESP now, it's nothing. It's just raw data.
Just sent as is. So it effectively is UDP for ESP now. It just sends the data and has no acknowledgement of it.
But it's basic. But technically, you can't say it's UDP because it's just
It's not, yeah.
the walk bytes.
Okay.
It's not in the standard.
So do you know roughly how much data it is sending, like every time it sends a burst to the controller to present the web page? How much data is it sending?
For acknowledge yourself or just say actual data.
Just actual data.
Just actual data. Every ESP-NOW packet, I'm using ESP-NOW V1, which is 250 bytes per packet.
Okay.
I have 250 minus. I can't remember how much, but I remember by heart I have 224 bytes of data I can put inside the packet.
Okay.
So the rest of it is just like service information, like SSR, MAC address, like sequence number, things like that.
Okay. So the MTU is 256 bytes, yeah?
224.
Minimum transmission unit.
It's like not really much, but if you using, as I've done just one string
It's a nice
with
amount of
chemicals,
data.
and then I pass it, which is more than enough.
256 bytes is actually quite a lot of sensor
It is.
data. You could send, 4 or 5 temperature sensors data. You could send pressure, humidity. You could send light levels as well, quantized light levels by the ADC. I think it's good. This is why it's a brilliant platform to build off of.
Yeah.
And you had a very good supervisor as well.
Yes.
I hear Nathan is very good.
Come on.
You're very lucky.
Come in.